Please welcome Professor Chen.
Thank you. Yeah. Okay. Yeah, it's my honor here to share some research efforts in RISC-V LLM interest group. Actually, it's in our school. So I come from the National Yangming Jiaotong University, and I would like to share some research effort result. Okay. As we can see, right now we are in, actually we can see the AI development is moving from the big data to the big variables, and we can envision in the future will become a big model era. So based on the lots of the statistics data we have and the knowledge experts system, we can have a very good AI assistant to write the business intelligence. But given with the so far, we right now already in a kind of the model with lots of the variables, just like BERT or even those large language model. So based on this model, we do need a lot of data. We need to have to collect sufficient data in order to train our own the model. But eventually, those models will getting mature. So, and then there are lots of thousands of a model will come up ready. It can become a big model era. Okay, so as we see lots of examples already shown, the generative AI would be very helpful to us. So the McKinsey report in the last year say even those application with the existing AI, there are lots of the contribution to the industry. By introducing the generative AI, we can even further improve up to 40%. But if we further combine those existing technology and with generative AI, we can even further improve up to the 70%. So overall, you can see the impact of the generative AI is quite huge. Okay, so but if we look at the details about the category, the generative AI can help. Most come from the STEM professionals, people with the STEM professionals, just like engineer or science and management. So you can see they can improve from about the 16% up to 30%. So the performance, the productivity improvement could be quite huge. And you can see there are other several categories showing the similar result. So as we can see, even in the United States, the Y Combinators, there are so many investment already put into the new startup regarding the engineering, regarding the sales and or customer support. Those are all the new companies come with the generative AI. But the recent report from McKinsey, again, they say if we already have a company with already have a good knowledge chatbot, or you have a good AI personal assistant, and also there are several generative tools ready, you can combine them together, and then you can even have a more powerful tool available for the company in order to produce, to improve the engineer productivity. Just like you can combine those together to get a customer-facing chatbot, or things like you can have an automatic FAQ generation. So those total value could be even further for your company future development. So this case could be quite promising in the future. This is another reason we can see is the open model like LLaMA or Mistral, things like that, is getting better than ever. So it could be with sufficient data, it could be it could approximately approach those closed model. Once those open model is ready, and then with our high performance architecture, we can come out even better application AI. So right now, let me just summarize the possible topics for the IC design with LLM. So it could be IC design for LLM. We particularly design the special IC or a computing platform for the executing the LLM. On the other hand, we may use the LLM, large language model, in order to improve our IC design flow. So yeah, there are lots of the topics, interesting topic can be pursued. Okay, so today I would like to just show a few examples. If we just consider the software side and how we can use the LLM improve our software design. Okay, and then later on we will show if we can have a good study or particular software effort in order to put the LLM, the tiny LLM in a very small system. Okay, so let me show the first. So the first thing, if you would like to have a large language model running on our processor, so it should be very small and very energy efficient. So the first goal would be try to minimize the model or even have the system design with a very small memory requirements. So it's a topic of the edge computing or so-called AI landing. So right now we already try to demonstrate a small model can be running on the Raspberry, running on the Jason Xavier, and the N3000 is a design and a new chip. And we can show some example on the Mac Studio. So we look at the problem, we divide the problem into 4 aspects. One is if we can see a good example, a good application can be demonstrated given those very small system. So this is application level. Within this level, we have to provide a very specific and precise prompt engineering. We have to provide the prompt template to show if those examples, those applications can be best fit to this tiny system. So this is the label between the application and the API. Under the API, we have to build some sufficient generated technology, just like a reasoning agent or the most popular RAG, retrieval augmented generation. And behind the API, there are lots of the foundation models available at this moment. But usually we have to look at the small model at this moment. And under the foundation, we can see there are lots of the hardware available, just like RISC-V or Raspberry or the industrial PC accelerator. So in order to fit lots of application into a small system, so we have to first build some the basic system module available. And we divide the problem into the 3 parts. One is that we have to provide the module in order to process the data at in a very efficient way, such that the inference can be easily deployed. So we have done the knowledge acquisition modules, things like the parser or the multimodality understanding. And then we have to consider how to perform the inference, the LLM reasoning within a smaller system device. So it kind of the fine-tune and the mixture of the small model within a small system. And later we have to see how those data can be come out, how the data can be presented in a reasonable way to your users. So once those things are done, and then we can have those application landing at the device. So we have done lots of the benchmarking and evaluation based on the laws of the hardware. Okay, and this is a small example. We show a small language model running on a two Raspberry. Those models include lots of the features here. Let me show you a demo. Oh, okay. That's too bad. I cannot see the demo video. All right. Yeah, if you are interested, let us show you later on. Okay, so, all right. Okay, so the previous example just show you a small model, how can a small model can be realized. The LLaMA 1 megabit, not 1 mega parameter can be run on the Raspberry. And it come out lots of the mixture of experts, small experts. And for the second part, I would like to show we can use the large language model how to improve our design productivity. So the point is we have to collect sufficient data in order to fine-tune a company-owned small or self-owned language model in order to perform our the productivity. And then eventually we hope the large language model can be landing at the edge devices. So this is several ways how to fine-tune the data or try to do the agent or the RAG. Okay, so let me show you the first example. This first example, we built a RISC-V expert system. It's basically it's kind of the knowledge assistant. So the source comes from the lots of public data available on the web, including the menu, textbook, material, or even the GitHub code. And also we collect several lots the Q&A from the Stack Overflow website. And the amount of data is not so huge, but it's good enough in order to answer some questions. And in addition, we particularly emphasize rather than a text Q&A, we also provide a very rich data format. This is quite useful for the engineer because we can show the state diagram, we can show the protocol, or we can show the state transition. So, there's a video demo here. No? Oh, it's too bad. Can you play it back? No? Too bad. Yeah. Actually, I have 5 demos. So this is the second. Okay. It's okay. Okay, let me go further. So the tool, second, it's just a regular RAG because we can see most companies, there are so many products with very large menus. And for the engineer or for his customers, I think it would be difficult for them to read those menu. So here I just show, given just like this example, there are more than 300 pages of the menu. And with a certain RAG or assistant, we have an advanced RAG system, and we can identify and can answer the question precisely, extract the information from the information retrieval. Okay, and here I would like to show, it's another demo. And here I would like to show if we have so many products there, and if you can perform the kind of the product comparison, show what kind of difference these two products can show. So we can specify the lowest field of interest you would like to see, and you just feed the data, the menu, and we can generate a summary report to precise compare side by side the key difference, the certain numbers or parameters difference between those different product spec. And it would be quite helpful to the engineer to see the particular points I have to look at. Okay, so this is the third tool. And also, we show this another demo, okay? Unfortunately, I can play it at this moment. Okay, the fourth tool is a summary. So for example, for the Intel, we have Gen 10, Generation 10, Generation 11, or 12. And I would like to see if the cache, regarding the cache, or regarding the bus bandwidth, or anything, the design parameters, I would like to see the key features between the difference between those generation. So with this tool, we can extract the information from all the documents, and the user can specify which feature you would like to look at, and then we can summarize it in a table. So, and finally, we produce the report as a PDF, and then you can look at the whole details. Okay. The fifth tool is a test case generator. We have the RISC-V assistant and the test case generator. We have a demo in outside booth. For the test case generator, as we know, we already have the Copilot tool ready for the engineer. But if you develop a certain code, you would like to take a test, you have to write a test case. Okay, so with this tool, you just put your code there, and then we try to understand your module, and we see your input and output. We let the LLM understand the input and output, and we generate the data for you. Okay, so the case is here. The user provides his code, and we have the parser. We provide the prompt, and then let the local on the large language model to understand the code. And we let the code generate the test case, the test data. And then we have a system to integrate with the compiling and execution and produce a result for this test case. And then it come up a result. So we build another prompt builder to look at the result and check if the coverage is good enough. Because for each test case, we would like to make sure if the test case can cover certain aspects. So we would hope the coverage could be close to 100 as possible. So this the group is trying to reach the coverage, to improve the coverage. So once under the constraint, the time or the resource you specify, finish the coverage execution, and then we can generate a report. We can have some sufficient test case for you, and we also report some error if some test case does not pass, or we have some result regarding the time limit exceed problem, and overall we release the final result as a test case, a test code for your input. So this is the overall system flow. We have some example outside. Okay. And finally, because there are lots of the interest in the tool can be pursued for in order to improve the productivity. So we build a studio. It's kind of the agentic AI flow. So user just plug and play the steps and the agents, and we can build the application, the Gen AI application to improve the engineer. So I finally conclude my talk here. We see right now we are still in the text training stage. So the conversation is just a kind of the text generation, the text sequence. But eventually we will enter the Chen state. Chen is a kind of, each problem can be divided into a certain steps, and each step can be solved by the different agent AI flow. And then we will eventually enter so-called causal inference state. So that each stage will determine some decision or make the decision or depend on certain input, and then eventually can be combined with a large language model together, and then come out very high level and powerful the system for the whole design phase. Okay, that's the end of my talk. Thank you.